As we have discussed, interrelationships means you'll have central in terms of non-central and non-central moments in terms of central. So this is the second part, expressing non-central moments in terms of central moments. Again, I'll write the same. What is mu r? Is it a central or non-central? Without dash stands for central moments. What is its definition? 1 by n sigma fi into xi minus x bar whole power r. Mu r means central. Central means you will get mu x bar here. Mu r dash are nothing but central moments. Fi into xi minus a whole power r. Now the statement here is expressing non-central in terms of central. So as we got the non-central here, you are going to have a statement with non-central on the LHS and central on the RHS. Again I repeat, expressing non-central in terms of central moments involves a statement where the LHS, the left hand side part of the statement, starts with RHS with non-central, and all the RHS consists of the other term called central moments. Here it is, mu r dash is equal to mu r plus RC1 mu r minus 1 mu 1 dash RC2 mu r minus 2 mu 1 dash square RC3 mu r minus 3 mu 1 dash whole cube plus mu 1 dash whole power r. So we have discussed the previous relationship where we have central in terms of non-central. So the LHS consists of mu r and all the RHS consists of non-central mu r. There we have observed that alternatively you are getting plus and minus. Here all the terms are with plus. The same mu r dash is equal to mu r RC1 mu r minus 1 mu 1 dash RC2 mu r minus 2 mu 1 dash square and so on mu 1 dash power r. So try to put these two statements parallelly and try to identify the difference between them. Okay. Now to prove this, both are similar, both involves the similar steps. There in the previous derivation, to derive central in terms of non-central moments, as we have the term central in the beginning, we have started the proof with mu r. Here it is non-central in terms of central. So we start with mu r dash non-central moment, which is nothing but 1 by n sigma fi into xi minus a whole power r. So when we have started with in the previous derivation mu r 1 by n sigma fi into xi minus x bar whole power r, we have added a and plus a, added and subtracted a there. So here you have a here, you need to add and subtract x bar. Got it, girls? In the previous one we have started with central moment where it consists of xi minus x bar. So we have added we have added and subtracted a there. Here the statement itself is non-central in terms of central. We are starting with non-central moment, which is nothing but 1 by n sigma fi into xi minus a whole power r. As you have a here, you are going to add and subtract x bar here. Okay, so what is x bar minus a? We know that x bar minus a is mu 1 dash. So 1 by n sigma fi into, as you have four terms, write the first two terms as it is xi minus x bar. This x bar minus a can be replaced with mu 1 dash. There you got a minus x bar, so by taking minus 1 common you got minus mu 1 dash. Here you got simply mu 1 dash. Let us take this as some other term previously as we have done xi minus x bar as capital Xi. So this mu r dash turns into 1 by n sigma fi into xi minus xi is nothing but xi plus mu 1 dash whole power r. So again we are going to use the binomial expansion. X plus a whole power n is nc0 x power n a power 0. As you have plus here, all terms you will get with plus. Ncn is 1, which is nothing but a power n. So here you will get 1 by n sigma fi into in place of r n you have r rc0 xi power r v1 power 0 is 1. So RC1 xi power r minus 1 v1 dash plus all you will get with plus. So again 1 by n sigma Fi is for all the terms. Let us multiply this 1 by n sigma Fi to all the terms. What is RC0 is 1 plus 1 by n sigma Fi RC1 xi power r minus 1 mu1 power mu1 plus 1 by n sigma Fi RC2 xi power r minus 2 mu1 square plus so on 1 by n sigma Fi mu1 dash whole power r. Again the same concept in the terms, in each term observe the terms which are independent of I and take it out of the sigma as sigma runs on I. So you will get mu r dash is equal to, okay, RC0 value is 1. So you will get that as 1 by n sigma Fi into xi power r. Next one RC1, it doesn't involve I, this can be taken out of the sigma, and also mu1 dash 1 by n sigma Fi into xi power r minus 1 plus RC2 mu1 dash square the last term is mu1 dash power r, we can take it out of the sigma 1 by n sigma Fi. So what is sigma Fi? Always capital N. So 1 by n, I want to replace this xi. What is xi here? Xi minus, we have assumed that capital Xi is xi minus x bar plus RC1 mu1 dash 1 by n sigma Fi into xi minus x bar whole power r minus 1 plus RC2 mu1 dash square 1 by n sigma Fi into xi minus x bar whole power r minus 2 plus so on mu1 dash whole power r 1 by n into sigma Fi is nothing but n, both cancels. So you will get what is mu r? Mu r stands for central moment, which is nothing but 1 by n sigma Fi into xi minus x whole power r. If you have r minus 1 here, you will get r minus 1, r minus 2, r minus 2. Using the same logic, you will get mu r dash is equal to, this is nothing but mu r plus RC1. The center term you have xi minus x bar with r minus 1 here, you will get mu r minus 1 into mu1 dash plus RC2. This in the power you have r minus 2. So mu r minus 2 mu1 dash square, here mu1 dash power 4. I think this is what we need to prove the non-central in terms of central moments. So you can find out the first 4 non-central moments in terms of central moments, and moreover before going to deal with that, you should know 2 more formulas. Okay, yeah, this is non-central in terms of central moments. Okay, thank you.